ratio compares two or more related quantities in a given order. And that's so important. So they're kind of like fractions, but they're not fractions. We're going to learn to write a ratio from a description. So again, the order counts. And we can actually simplify a ratio like we can simplify a fraction. That idea is the same. You can compare two things, three things, and a colon is this. So if I said I had 2 to 3, those dots on top of each other, that's a colon. Ratios are expressed without units. So this could be 2 marbles to 3 marbles, but the ratio of marbles is 2 red to 2 black, 2 to 3. Ratio can be simplified like in a similar way to a fraction. So sometimes ratios are like fractions, but they're not. If I had a fraction, we can divide both of those by the same quantity. 4 divided by 2, 6 divided by 2. I'll put there divided by 2 in there. And that gives us a simplified fraction. In the same way we can do 4 to 6 can be simplified 2 to 3. So a ratio is simplified if the numbers that make up the ratio have a common factor. This is exactly the same as simplifying a fraction. The common factor there was 2. Both 4 and 6 have a factor of 2. Divide both of them by that same factor, and we are then simplifying that fraction, now ratio. And if we divide all the numbers in a ratio by their highest common factor, then that gives us the simplest form. Remember, you might not know the highest common factor, but you can find any common factor, divide them both by that common factor, and then look again and say, oh, can I divide it again? Can I divide it again? Until you get to the point where there's no common factors, and then your job is done. So you don't always have to just jump to the highest common factor. Okay, we've got 3 white and 4 dark chocolates. I don't know which one you prefer, but I just eat them all. Write each of the following as a ratio. Okay, so now this is where the words count. We want the ratio of, first, white chocolates to dark chocolates. So we know we have 3 white chocolates and 4 dark chocolates. So for every 3 white chocolates, there are 4 dark chocolates. Now notice that the only reason I wrote 3 first is because I know I have 3 whites and I have 4 darks. But notice this is not the same as 3 out of 4. It's not. In this case, I have actually 1, 2, 3, 4, 5, 6, 7. I actually have 7 chocolates. So a fraction is parts of the whole. This is a number of 1 to another related quantity. All right, let's go back. So now, the first time we were saying we wanted a ratio of white to dark. So now I'm going to change the rules a little bit here. And this time I'm looking for the ratio of dark chocolates to white chocolates. So I have 4 dark chocolates and I have 3 white chocolates. If I want the ratio of white to dark, that's the order, 3 to 4. But the ratio of dark to white is 4 to 3, and they're different things. So a shop shelf contains 2 cakes, 5 slices, and 9 pies. Write each of the following as a ratio. So, ratio of cakes. How many cakes? 2. 2 slices. How many slices? 5. So that, it's not a comparison to the whole. It's a comparison of, I've got 2 cakes to 5 slices. For every 2 cakes in that case, I've got 5 slices. Now I want the ratio of cakes. Okay, that's 2. 2 slices, what do we got there? It says 5. To pies, well, you know what? We can do that too. We've got 9 pies. And finally, the ratio of pies. So because the word pies comes first, I'm going to write a 9, and I'm going to write my colon there to cakes. And it tells me that there are 2 cakes. Great, that's it. So you just have to follow the instructions. So in a way, they're like fractions, but fractions are always parts over the whole, where ratios is not that. It's comparison to things. So now I want to simplify these ratios. For every 4 green jelly beans, I've got 10 red jelly beans. But that's not the simplest ratio, because the reality might be I have 40 of the first color and 100 of the next color. So the ratio is the simplest form of that. So just like we would do with a fraction, we're going to divide both of those by a common factor. 2 goes into both of them. So 2 is a factor of 4. 4 divided by 2 is 2. And 10 divided by 2 is 5. I'm done. That's it. I can't simplify that anymore. So my ratio of one colored jelly bean to the other is 2 to 5. So now I've got 3 numbers. The quickest way is to find the highest common factor between these 3. And I bet you could figure it out, because 3 being a prime number only has 2 factors. 1 and itself. I know that my highest common factor is going to be 3. If I divide all 3 of these numbers by 3, 3 divided by 3 is what? 12 divided by 3, I might use my calculator just to check, is 4. 15 divided by 3, I think is 5. So in reality, I might have 3 oranges, 12 apples, and 15 pears. That actually reduces to a ratio of 1 apple, 4 oranges, and 5 pears. Now the last one looks tricky, but remember, if we have a ratio, I don't care if it's points or kilograms or kilometers. So I'm just going to reduce that to the numbers, 15 to 10. That's my ratio. I'm going to have a good guess that 15 and 10 are both divisible by 5, and I'll bet that's their highest common factor. 15 divided by 5 is 3, 10 divided by 5 is 2. So 15 points to 10 points reduces to a ratio of 3 to 2, and that's how we would say it, putting a colon in between 3 to 2.